Oh, hi everyone. Thanks so much for showing up here, Math Learning. I'm Mr. Jennings, and we're reviewing our factoring skills from the last 2 years. So one of the most common thing will be like, how do I do this one? And the main thing that the student hasn't done is look for common factors first. It's so just makes your life easier, and it's like this habit that you always have. You look at something and you're like, can I common factor it? So look for that in like any example, any problems. It's almost always a road to improving the problem. People talk about like man, multiply, add numbers, or X game. I'm an X game truther, so that's like the life that I lead is I play a lot of X game. I also use decomposition and grouping. That's my preferred method. If you use another method, if you factor down under, if you use box method or rational factoring, slide and divide. If you get the stupid answer, that's fantastic. Get the answer. Right? That's what we want. These are just methods to get to the top. And then we want to be able to write things in fully factored form. That's what we're looking at. So let's go. If I need to fully factor this, I am X game. I want to multiply to this number and add to that number. What are my magic numbers?
7 and 3.
What flavors of 7 and 3, please?
-7, -3.
Yes. So then I just go ahead and say, well, this fancy function f of x is equal to x minus 7 multiplied by x minus 3. What do you suppose I do next, everyone? If I wanted to find the zeros, I'd set it to 0 and then find the zeros, yes. But I think you'll recall this like funny thing I have an almost religious zeal. If I ever write down an equal sign, I want to make sure my equal sign is telling the truth. So I check my work at this phase, okay? I'm going to go ahead and check my work. How would I check my work? Just expand, yeah. X times x is x squared. This is minus 3x and minus 7x. So that together gives me minus 10x. And minus 7 times minus 3 is, oh, it's not negative 21. It's positive 21. Very good. So that step of checking your work is so important. Have this habit every time you write a line. Check the previous line. Make sure you're still telling the truth. It's good communication. It irons out any problems in your communication. You'll discover errors before you carry them on for 5 lines. And even just doing that check in your mind helps build your mental math and your understanding of all the things that are happening. So I can't emphasize it enough. It's so valuable. Okay, let's keep going. All right, let's fully factor. So wait, I got 2's and stuff in there. What do you suppose I do with this one? I absolutely common factor first, yes. So this is f at h is equal to 2 multiplied by h squared plus h minus 12. And then in my mind, I multiply that 2 in, and I make sure it still matches the line above. Now when I have a common factor like that, do I just discard the common factor, I get rid of it in this case? Yeah. He's smiling at me. He's like, yes, I'm going to say the thing that's wrong. I'm going to fall for your trap, Mr. Jennings. No, don't fall for the trap. Okay? If this question were 0 equals 2h squared plus 2h minus 24, this is like a categorically different problem. That's a single variable, and we have a single solution, or in this case, 2 solutions for that variable. We want to just find those 2 values of h that make the expression equal to 0. This is a function. So if I divide both sides by 2, then I end up with my function divided by 2, and that's janky to the extreme. So don't do that. We have to keep that 2 in this case. In this case over here, you can absolutely divide both sides by 2 and say that it's equal to this. Okay, and then I factor that, and I find my 2 magic numbers that multiply to minus 12 and add to 1 are 4 and minus 3. So without further ado, we say that f of h is equal to 2 times h plus 4 times h minus 3. Done. That's the function in fully factored form. Am I right? Yeah, I'm right. And then I check it in my head, and it works out. Okay, carry on? Carry on. Okay. Oh, wait. I was hoping that there'd be common factors, but there ain't none here. So what can I do? Wow. Well, in this case, I'm still playing X games. But now I'm going to use the decomposition method, which also works when the A value, and by A, sorry, awkwardly named example, because here our variable is also A for some reason. But this coefficient there, when that's not 1, I'm going to use a decomposition method. You may have your own method, okay? So in this case, what I do is I take 10 and minus 7, the A and the C, and multiply them to get minus 70. And then I want to multiply to minus 70 and add to positive 9. So maybe that's hard to find for me. Maybe I'm having trouble finding it. So I'm going to go ahead and factorize this. This is 7 times 10 times 2 times 5. And one of them is negative somewhere. So it's like there's a negative 1 lurking in there somewhere. Here are my prime factors. Well, minus 1 is not prime, but 7, 2, and 5 are. And now I want to find an arrangement of those which, well, multiplying to minus 70 will add to positive 9. Here's my hint for you. One of them is positive and one of them is negative because we are multiplying to a negative number. So I effectively want two factors that multiply to 70 whose difference is 9. Because one's positive, one's negative. I'm going to smash them together to make my B term. And so those are 14 and minus 5. And I can see that like I can play this game and arrange those two factors together to make my 14 and my 5. So now, next, I write this is equal to 10a squared minus 5a. Just putting the 10 and the 5 looks like it's going to go together easier. I don't know, it just looks easier. And then plus 14a minus 7. And I check. And I stop here. And I make sure the line I just wrote is equal to the line above. Pretty easy. Minus 5 plus 14 is indeed 9. And when I do that, I'm reinforcing my understanding of why these numbers are useful and how I'm using them. Now I go ahead and factor by grouping. So I group those two and I group those two. And I take the common factor out of both. So my first group looks like, oh, I've got a 5a in there. And I would have to multiply that by 2a minus 1 to recreate this grouping of terms up there. And I check my work and it matches. And then the next one, I have a common factor 7. So I'm going to take out 7. And then that's going to be multiplied by 2a minus 1. And holy goodness, by some kind of mathemagic, I have created a common factor in both of those groups. And the common factor just happens to be a binomial. So I can factor that binomial out of those two terms, just like it's a common factor. So let's put it in front for fun. 2a minus 1 multiplied by 5a plus 7. And there's been a plethora of opportunities to make an error by this point, so I check my work. So I check my work here. I'm going to go here. That's my 10a squared. And then this gives me 14a, and that gives me minus 5a. And the last time I checked, 14 minus 5 was 9. And then 1 times 7, but it's negative, is negative 7. So I'm good. I'm happy with that. And so I've checked it. And I check it mentally or I write it down. Questions? Let's keep going. Let's keep going. All right. But what if we have one like this? Well, it's exactly the same. So I do 5 times 8 is 40. And then, so I'm playing this x game, so I want to multiply to 40, but add to minus 14. And when I'm adding to a negative and multiplying to a positive, both are negative, and this one is pretty easy. It's minus 4 and minus 10. And then it's exactly the same as the example up above. Emma? Yeah, go for it, yeah. Okay, but what about this one, Mr. Jennings? How would you do this one? Oh, well, what do you think? The decomposition method is pretty powerful. I could just go ahead and decompose, but it would be like saying, pick up those weights and clean your room. Why would I pick up the weights and then, while holding them, clean up my room? Why not do one and then the other? Like, you don't need to carry that extra weight around. Taking the common factor out is like picking up the weights, putting them down, and then tidying your room. You don't need to carry them around the rest of the problem. So, I common factor first. F of x is equal to 2 multiplied by 3x squared minus x minus 10. And now I've just got an easier x game to win. I've got an easier thing to factor. Life is easier. That's how I want you to feel. Like, life is so easy. Mr. Jennings, it used to be so hard, but now it's so easy. I love it. And I want to multiply to minus 30 and add to minus 1. And those magic numbers are minus 6 and 5. Hooray. Let's go. So this is 2 times 3x squared minus 6x plus 5x minus 10. Okay, and this is still a function. It's f of x. If it were equal to 0, then after I'm done all this, I set all my factors equal to 0 and find out what those x values are. Okay, let's keep going. So here we have 2 times. Here, this factors. Notice, I have this neatly in brackets. I keep it in brackets so that it behaves properly. All of that gets multiplied by the 2, because that was a common factor that I pulled out ages ago. It's the first thing the bouncer pulled out of the party, and he's just going to wait outside for his friends until they're all arranged nicely into factors. Okay, so leave that alone. All right, so 3x squared minus 6x has a common factor 3x, and that would multiply by x minus 2. And then this group here has a common factor 5, so we are plus 5 multiplied by x minus 2. And I end that little factors bracket, and then I end this bracket here. So all of the brackets are keeping everyone well behaved. The bouncer's getting the fight organized inside the bar, while the 2, the big troublemaker 2, is just waiting outside for his friends to come out. Okay, so this is equal to 2 multiplied by 3x plus 5 multiplied by x minus 2. That's factoring out that common binomial factor, the x minus 2. And now, I just move on to the next problem, right? Right? Check it. Yes, always check. I can make an error here. I will tabulate my errors in this class and keep them somewhere in the room. I haven't made an error yet. So anyway, if I'm checking something like this, I'll show you some efficiencies. One thing I would do is I would check my terms, my original expression term by term. So when I check my x squared term, my quadratic term, I go 2 times 3x times x. That's indeed 6x squared. Okay, and then I go 3x times minus 2 is minus 6x plus 5x, so that's minus 1x. Again, multiplied by 2 is minus 2x. And then to check my constant term, that's just going to be, multiplying all the numbers. So 2 times 5 times minus 2 is indeed minus 20. So it checks out. And I'm very satisfied. So I keep going. But we've only been factoring trinomials, and this ain't no trinomial. This is a binomial. So what can I do? What do I do with this?
Difference of squares.
This is a square, and I subtract another square. Okay, so people know the visualization for a difference of squares. This is just so beautiful. I love it, and I want to show it. Okay, here this is my side length x, and this is also x, and so this has area x squared. But then I'm going to take a bite out of it that's y squared, and so where's my y squared? It's over here. All right, there's my square that's y by y. And this is y squared, and I'm removing that. Once I do that, I can see that I could rearrange this. I can take this whole piece here, which has this side length, x minus y. So this one here, this is x minus y. And this whole region, this is also x minus y over here. I can move this whole region down here and make a rectangle. And then this is length y over here. So I have x plus y on one side and x minus y on the other side. When you have a difference of squares, like x squared minus y squared, it always does this rectangle trick. It's very cool. It's beautiful. So here, I factor into 2x plus 5 times 2x minus 5. It's better than it seems. Okay, so at that point, I check. and I get 0x. I kind of do have a trinomial because my b value is 0. And it's 0, of course, because these cancel. 2x times minus 5 is minus 10x, and then this is plus 10x. So there's your difference of squares. And maybe that's all I do for today. I seem to be struggling. Okay, so try that out and let me know how it goes.